When an elastomer seal is compressed, it generates a reaction force, also known as sealing force. The sealing force is the elastomer pushing back against the surfaces that are compressing it, which comes from the stored energy within the elastomer. This forms the primary seal. However, over time, this stored energy starts to dissipate and the sealing force of the elastomer pushing back weakens. When the sealing force drops too low, the seal becomes less effective and can result in leakage. Compressive stress relaxation, CSR, is the decrease in sealing force over time. The rate of CSR can be accelerated by exposure to chemicals and/or elevated temperatures which attack the polymer backbone or cross-linking system, reducing the sealing force. Compressive stress relaxation occurs because the elastomer has become permanently deformed in its compressed state. When the elastomer is no longer compressed, it has a flattened appearance and doesn't return to its original shape. This is known as compression set. It's important not to confuse compressive stress relaxation with compression set. The two are very different. CSR is the decline in the sealing force the elastomer exerts, pushing back on the surfaces around it. Compression set is the amount of deformation that has occurred, quantified as a percentage loss in shape compared to the original dimensions. CSR is measured in a laboratory using the standard ISO 3384, which includes two methods, A and B. Both can be used in air or liquids. Method A is conducted at room temperature, and any chosen test temperature up to 350 degrees Celsius. Method B is conducted at room temperature only. Both of these methods can be done in two different ways, continuous and non-continuous measurement. Continuous uses a small portable rig with a load cell that can be placed inside the oven of CSR equipment or in a laboratory room. The rig is connected to a computer that constantly records the force data in real time. The non-continuous method uses a test cell to apply the compression. The cell is placed in the test environment and removed at regular intervals, and allowed to cool if required before the counterforce is measured using a tensile tester. The sample is then placed back in the test cell and returned to the test environment. CSR is measured by compressing a standard test piece to a constant strain and measuring the force exerted by the elastomer test piece at specific time intervals under specified temperature conditions. The decaying force is expressed as a percentage of the initial sealing force. In this example, two materials have been tested at room temperature. After 150 hours, material 1 has retained sealing force of 50%. And material 2 is performing less well, with a retained sealing force of 40%. Different applications will require a different minimum retained sealing force, dependent on the seal geometry and the pressure and temperature cycling of the application. In this example, the sealing force has leveled off for materials 1 and 2, demonstrating that they continue to retain their remaining sealing force beyond 70 days, with little or no further relaxation. Material 3 has continued to decline over time and would not be suitable for long-term use. Stress relaxation graphs can be used to create an Arrhenius plot for rubber materials, which helps estimate expected seal life. The procedure is described in the standard ISO 11346. CSR tests are conducted at 3 different temperatures until the material's sealing force is 50% of the original value. The time to reach 50% for each temperature is then plotted in an Arrhenius plot. The best temperatures are chosen so the test time for the highest temperature is at least 1 week, and the time for the lowest temperature is at least 9 months. To create the Arrhenius plot, a straight line is drawn through 3 points and extrapolated to the temperature the tested material is to be used at to get an estimation of the lifetime. In this example, this material would be expected to last 50 weeks at an operating temperature of 50 degrees Celsius. If operating at 250 degrees Celsius, it would be expected to last 10 weeks, that being when it has reached 50% retained sealing force. Conducting CSR testing on sealing materials that match your application conditions relating to operating temperature and fluid media can provide several benefits. Most notable, the ability to benchmark materials for long-term sealing performance, with a prediction of estimated seal life, which helps with planning preventative maintenance cycles. Find your nearest sealing specialist by heading to www.prepol.com.